Right. So hello guys, welcome to the another session of SISYA class JEE foundation series. So today we are going to delve into the physics. So that is kinematics, equations of motion. That too we are particularly focusing on the graphs part, because so from the kinematics, all of you are getting nearly 6.6% of the marks weightage in your upcoming JEE mains exam. So this is one of the most important topics you need to cover and you need to focus on. So if you are one of the students that belong to 8 or 9 or 10 grades, so this session is especially for you to build up your skills for the JEE exam. Okay, so come on, let us dive into the our session. So before diving into our session, let me introduce myself first. So this is Ram Prasad KSVNS, the master teacher at SISYA class. So I did my masters in physics from Andhra University. I have more than 8 years experience in training students for IIT JEE, and I interacted with more than 40,000 students across India. Now you can also check my profile on Google also. So let us delve into our concept today. So today, equations of motion, when coming to the equations of motion, so already in our last session we have already discussed about the three core equations of motion, right? So one is v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. Those three core equations of motion always going to give you the relationship between the variables. Those are displacement, okay, final velocity, initial velocity, acceleration, and time period. So whenever the three of the variables or some of the variables are given and you need to find the other variable in a particular scenario, you are going to use one of the or some of these core equations of motion, right? So when coming into the graphs, so for suppose if an object is in motion, okay, and the information about its motion, like its initial velocity, final velocity, instead of the numerical values, if a graph is provided to you, so what if a graph is provided to you, how can you decode that graph, and how can you get all the variables which you require, and how can you find out the other variables that are asked in the question? So let us go into the graph part now. So we have basically two different types of graphs here for the equations of motion. One is displacement time graph, the other one is velocity time graph, right? So for the displacement time graph, we are going to take displacement on y-axis, right? You are going to see here, and time, which is calculated in seconds, has to be taken on the x-axis, right? So this is the graph which is, you know, monitoring the movement of the object, okay, so based on the time and its displacement from the initial position, right? So when coming to the displacement time graph, the details, if you are getting, if your graph is a inclined straight line to the x-axis making some angle, if it is an inclined straight line, it means that your object is moving with some uniform velocity. It means its velocity is not changing with time, okay? So in this case, the object is said to be in uniform motion, as well as its acceleration is set to be 0 meter per second square, because the rate of change of velocity is not changing with the time here, okay? So in this case, if your graph is a straight line which is inclined to the x-axis, and if you are getting a graph which is a straight line again, and if it is parallel to the x-axis, for the displacement time graph, if you are getting a straight line which is parallel to the x-axis, it means that the position of the object is not changing with the time, right? The position remained constant throughout the time period, and here the body is said to be at rest, okay? So remember that here the velocity, what will be the velocity now? When the object's position is fixed, if the object is at rest, what can you conclude by that? It means the body is not moving, the object is not moving, and its velocity would be completely zero in this case, okay? Now what if the graph is a straight line, but here in this case, if the theta that is making, if the angle that is making with the x-axis here, if you see the angle which is making with the x-axis, right? So here if you see the angle with the x-axis is more than, this theta is more than 90 degrees. So here in this case we call it as negative velocity. It means the position of the object is gradually, the final position, okay, the position from the distance from the mean position, or the distance from the initial position is gradually getting closer and closer to again initial position. Okay, the final position is gradually closing to initial position, right? So when the graph is more than inclined more than 90 degrees with the x-axis, it means the velocity is negative. The body is coming in the reverse direction towards its initial position. So this is what we need to remember this. Okay, now on a displacement time graph, slope equals velocity, right? So wherever you are going to find the slope, okay, so here the slope is positive, here the slope. So how to find slope first? So how to find the slope here for the graph? So first you have to take the theta. What is the theta the graph is making with the x-axis? So for this theta you need to find tangent, tan theta. So tan theta equals slope of the graph. So slope of the graph for the displacement time, okay, for the displacement time graph, if you are finding the slope, it gives what? It gives velocity. If you are getting slope positive, it means uniform gradual increase of velocity. Okay, if you are getting the slope negative, here the tan theta becomes negative if the theta is greater than 90. Okay, so here in this case the slope would be negative. So here in this case, so then the velocity also would be negative. When the slope is negative, velocity is also would be negative. And what about this slope? Any line which is parallel to the x-axis, the slope of any line which is parallel to the x-axis always what? 0, right? Slope is 0 completely, because the angle between this line and two parallel lines, actually this x-axis, and if you see this case where the body is at rest, so these both lines are parallel, right? So the angle between two parallel lines is 0. So tan 0 is 0, right? So the slope is 0 and the velocity is also 0, right? In this way we need to decode the graph. Next, a straight line represents a constant velocity. Actually a diagonal straight line represents a constant velocity. What happens if you get some curves here in place of straight lines? If you are getting curves, it means the velocity is not constant, the velocity is variable. Okay, the velocity is either it is not constantly or gradually increasing, it is variably increasing. Okay, so in that case the acceleration also would be coming. If you are seeing any kind of curves in the displacement time graph, it means there is acceleration for the body. Or if you are seeing only the straight line graph for the displacement time graph, it means there is no acceleration, only velocity is there for the given object. Now a curved line represents acceleration, fine. A positive slope represents motion in the positive direction. A negative slope represents motion in the negative direction, right? Now negative direction means what? So it just reversed its direction. If I am moving forward, okay, my velocity would be positive. If I am moving backward again to my original position, my velocity would be negative. That's it. Now a zero slope horizontal line represents a state of rest, right? So this is the graph where the body is at. This part of the graph telling us that the body is at rest between the 3rd and the 6th seconds of its motion. Totally the body is in motion for how many seconds here? By this graph, what can we conclude? The body started its journey at the 0th second. So up to the 3rd second, gradually its velocity okay, gradually there is a uniform velocity, and by the third second the body has reached 40 meters, right? From the third second to sixth second, the body remained at rest because there is no velocity, right? The body is at rest, where at the 40-meter mark the body is remained at rest up to the sixth second. Now after the sixth second, again the body started to move because the slope continued downward. It means the velocity, there is a velocity for this body, and the velocity is in reverse direction now. Okay, as the slope is negative, the body is coming back to its original position in this case, right? So from the sixth second to ninth second, so in the span of 3 seconds, again the body returned from this 40 meter position towards the 0 meter position, which it is there in the beginning of our motion. So again gradually its displacement got reduced to 0. Again it returned to its original position by the end of the 9th second. So that is what we conclude by this graph, right? So I hope you understood this graph, right? So I hope you understand, right? So now coming to velocity time graph. Now coming to the velocity time graph, what happens? So if you are studying how the object's velocity is increasing or decreasing with respect to time. Now we are not studying with the displacement of the body. Now we are studying the velocity, like the rate of change of displacement we are studying with respect to time. You are taking velocity on y-axis and you are taking time on the x-axis. The time is measured in seconds and velocity is measured in meter per second, right? So there are some cases here again for the velocity time graph. Let us see now. For the first case, if you are seeing a straight line graph which is parallel to the x-axis for the velocity time graph, what it means? It means the velocity is constant with respect to time, because when the time is passing, okay, even though the time is passing, the velocity is remaining at the same value. The velocity is remaining at the same value. It means the body is in uniform motion. So whenever you are seeing a straight line graph which is parallel to the x-axis for the velocity time graph, it means the body is in uniform motion. Okay, there is no acceleration or deceleration in this case, right? So now what happens if you are seeing a straight line, inclined line? Okay, if you are seeing an inclined line or a diagonal line making some angle theta with the x-axis, okay, making some angle theta with the x-axis, what it means? Here it means the velocity is gradually increasing. The velocity is gradually increasing with time. The rate of change of velocity is there and it is gradually increasing with time. Uniform increasing is there. Uniform rate of change of velocity is there. When there is a uniform rate of change of velocity, see, rate of change of velocity means acceleration, right? So uniform rate of change of velocity means here uniform acceleration. In this case, the body is having uniform acceleration, right? Uniform acceleration in this case. Now what happens here? There is a curve. You are seeing the curve is going steeper and steeper and it is rising up, right? Means the velocity is increasing, but it's not increasing gradually, but it is increasing in a curve. Curve means variable, right? So whenever you are seeing curves means variable. Straight lines means constants. Straight lines means constant or gradual, okay? Whereas curves means variables. So if you are seeing a curve for the velocity time graph, the velocity is variable here. The velocity is variably increasing. The rate of change of velocity is variable. It means the rate of change of velocity is acceleration and variable acceleration. Here we have variable acceleration, right? So these are some of the velocity time graphs. These are the most important 3 situations we are going to see in the upcoming numericals. Now coming to the next point in the graphs. So here, so again I'm showing you the velocity time graph for a better understanding of all of you, right? So here if we consider this graph, what can we derive from this? So let us see this graph. What can we derive from this graph? Let us see from the beginning. So here the time started from 0, right? 0th second. The time started from 0th second, right? The body started its journey from the 0th second, right? It started its journey from 0th second. At 0th second, its velocity. What is its velocity? The velocity is also 0 meter per second, right? So it continued its journey, right? So if you see, the graph is gradually increasing, right? The gradually a straight line we got. Straight line means constant, right? So the velocity constantly increased, right? The velocity constantly increased up to the 4th second. So if you see, for the first second, it is approximately at 1 meter per second. By the end of third second, it is approximately at 2 meter per second. And by the 4th second, it is at 3 meter per second. Means its velocity is constantly or uniformly increasing. Means the rate of change of velocity is uniform. Here you can say that there is a uniform acceleration. So from the 0th second to the end of the 4th second, there is a uniform acceleration for this body. Now coming to its journey from 4th second to 6th second. Now what can we conclude here? So here if you see, there is a straight line from 4th second to 6th second which is parallel to x-axis, right? See, at the 4th second, its velocity is 3 meter per second. At the 5th second, again its velocity is 3 meter per second. Again at the end of the 6th second, its velocity is 3 meter per second. Means its velocity is not increasing with the time. Even though the time is moving up, the velocity remained at 3 meter per second. It means there is no acceleration. So from the 4th second till the end of the 6th second, right? So there is no acceleration here. There is no acceleration. It means the body remained at uniform motion at this particular time instant. Now again, seeing from 6th second to 7th second, in the span of 1 second, its velocity increased from 3 meter per second to 6 meter per second. 6 meter per second. It means what? So in this particular interval of time, in the span of 1 second, the body has acceleration. That is the reason, a very high acceleration. That is the reason its velocity increased from just 3 meter per second to 6 meter per second, right? Here there is an acceleration. Again there is a straight line. So if you see here, there is a straight line. So we can call it as a uniform acceleration. Now, if you carefully observe from the 7th second till the end of the 10th second, the graph gradually moved down, right? The graph gradually moved down. Whenever the graph is moving down, it means the body is reversing its direction. The motion of the body is in the reverse direction. That's why the graph is coming down. So here again it is a straight line. It means uniform. Now what about this? The velocity gradually decreased. Right? The rate of change of velocity gradually decreased from 6 meter per second till it reached 0 meter per second by the end of the 10th second. So there is uniform, can I write acceleration? Uniform acceleration. Can we say uniform acceleration here because it is a straight line, uniform, and there is a rate of change of velocity? Can I write uniform acceleration now? So as the acceleration is in the reverse direction now, as the velocity is in the reverse direction, right? The velocity is decreasing, not increasing. So here we cannot say that it is uniform acceleration, but we can say that it is a uniform deceleration, right? As if you say the acceleration in the negative sense, it would be deceleration. So this is the uniform deceleration because the body's velocity, the rate of change of velocity got decreased gradually from the 7th second till the end of the 10th second of its journey, right? So now what if I want displacement from this graph? What I want displacement? How can I find displacement? Can anyone in the comments section? Right. So here, if you see, how can you find the displacement in this particular graph? So there is a velocity which is there on the y-axis and there is time on the x-axis, right? Now how can I get the displacement? So if you see, what is velocity? Velocity means velocity is equal to displacement by time, right? Rate of change of displacement, right? Displacement by time, rate of change of displacement. Now what if I bring this time towards the LHS? So time into velocity equals to displacement, right? Time into velocity gives displacement, right? So I have the time values here. I have my velocity values here. So if I multiply the time period with the velocity, I can get the displacement, right? So here, wherever, see, here if you particularly observe, this is a plane. A graph is a plane, right? A plane will be having length and breadth or a length and height, right? So here I wanted to product the length with the height. I wanted to what? Multiply. I wanted to multiply the length with the height or the length with the breadth, because length means time, breadth means velocity. If I wanted, see, I wanted to multiply this velocity and time in order to obtain displacement. So mathematically speaking, if I am multiplying this length with the breadth, it gives area, right? So length into breadth in mathematics gives area. So if I am, technically speaking, if I can calculate the area of this plane of the graph, I will be getting what? Displacement, whatever I needed, right? So the area of velocity time graph, the area under velocity time graph gives what? Area under velocity time graph gives displacement. So if I want displacement, I need to find the area of velocity time graph. Got it? So next, now whenever I am seeing curves in the graph, whenever I am seeing the curves in either displacement time graph or velocity time graph, so a curve means generally either it is in the case in the like a U shape here, like a U shape or an inverted U shape. So this shape is called as parabola. A U type structure is called as a parabola. Okay, this kind of curve is called parabola. So where it is open on both the ends, okay, it is open on both ends upward, okay, and it is closed in the downward, okay. So this is called as an inverted parabola, where it open in the downward, so this is called what? Inverted parabola. So whenever you are seeing these shapes in graphs, what they mean? So whenever, if you see a parabola shape, right? So let us study. So in the parabola, if you study the first half, right, the graph is decreasing, right? In the first half of parabola, the graph is decreasing. It means the motion is in the reverse direction. Like the body is coming towards the what? The body is coming towards the mean position or the initial position with respect to time. Okay. So the body is returning. Whenever you see the graph is coming downward, the body is returning to its original position. Whenever you see the graph is going upward, it means it is going far and far away from the initial position. So this is what this parabola says. So this parabola, if you are seeing a parabola, it means in the first half of the parabola, the body is coming towards its original position, the mean position or the initial position, and the later half of the parabola will be telling that the body is going away from the original position, its original or the initial position. Now, the inverted parabola. What inverted parabola says? Just the reverse of the normal parabola. Here the inverted parabola will be saying that the body started its journey from its original position, like near to its original position it started, and it gradually moved away from its original position until the half of the journey, and again it returned back to its original position as the graph decreased, as the graph went downward by the end of the journey, right? So this is what parabolas speak. And also parabolas are not straight lines, those are curves. These are curves and not straight lines. So this is not a V shape. V shape consists of two straight lines, right? So this is not a V shape, this is a curve. Curves means not uniform, non-uniform motion. Always parabolas will be speaking about the bodies or the objects under non-uniform motion. They are not speaking about the uniform motion, okay? If you are seeing any kind of straight lines, it means uniform motion. And if you are seeing, if you are seeing the parabolas, okay, in the velocity time graph, okay, velocity time graph, it means the body is moving with the variable acceleration. And if you are seeing the parabolas in the displacement time graph, okay, the body is moving with variable velocity, right? Next, coming to the topic. Now, how to find the instantaneous and average accelerations on velocity time graph. So whenever there is a graph given to you, this is a VT graph. So on the y-axis, I have taken velocity here. On the x-axis, I have taken time here. So VT graph, this is a VT graph. So in a VT graph, if you are seeing a curve, and if you want the acceleration at any instant of the time, so what you need to do, you need to select a point where you want that acceleration at that particular instant, and you need to draw a tangent at that particular point. So tangent means what? Tangent means a straight line that passes through only one point on a curve. Okay, so if a line touches a curve at only one point, it is called as a tangent. Okay, so whenever you are drawing a tangent to a particular curve, so this tangent will be touching that curve at only one single point, right? So, and if you find out the slope of this line, whenever you are drawing a tangent to this curve, then you need to find the angle. You need to measure the angle that this tangent is making with the x-axis. You need to take this angle and you need to measure tan theta. Then this tan theta will be giving you the instantaneous acceleration, of this particular object at this particular instant of time. So in this way, you are going to find the instantaneous acceleration for any object in the given curve. Now, what about the average acceleration? How can I find the average acceleration, right? So to find average, at least I need 2 points, right? So I can find average only by at least if I have two values, I can take average of both of them. With only one value, I cannot calculate the average, right? So I have to take, for finding the average acceleration, I have to take at least 2 points, any 2 points on this curve. See, for example, this is a point A, this is a point B on curve. Okay, so I have to connect these both points with a straight line, right? And I need to extend the straight line up to the x-axis, and I need to take the value of theta that is making, okay, with the x-axis. Again, the same process, I need to find the tan theta. So if I am doing in this manner, I would be getting the average acceleration between the point A and the point B of the journey of this particular object. Okay, so in this way we are going to find the average acceleration and instantaneous accelerations. Got it? Now, so these are some of the basics we covered before going into the numericals. Now going into the numericals. The first one, what is the total displacement covered as per the following velocity time graph? Now they are asking to find what? Displacement. Here they are asking for displacement in this particular graph which is given over here. So I already told you, if there is a velocity time graph, how can I find the displacement? The displacement is nothing but the area under this velocity time graph. So this is the graph that I got, right? And if I find the area of this graph, I can find what? Displacement. If you see here in this question, it is in the shape of what? This is in the shape of what? If I connect the two base points, this is a shape of a trapezium. This is its entire journey, right? From the 0th second till the 30th second, the object has this kind of graph, right? So first let us break down this graph, what we can understand from this graph. So at 0th second, the body started from its motion, right? The body started its motion at the 0th second. At 0th second, the body is passing how much? 0 meter per second, 0 meter per second, because it is 0. Now after spending 5 seconds, after going 5 seconds in our journey, the body now has nearly 15 meter per second. The body is passing near 15 meter per second. By the end of the 10th second, the body is passing 30 meter per second. So here the velocity is constantly or the gradually increasing. The velocity is gradually increasing. As the velocity is gradually increasing, we got a straight line. It means the body is under uniform acceleration. Okay. So again here the body is maintaining at what? 30 meter per second from the 10th second till the 20th second. So it is under the uniform velocity. Again it got the negative velocity here. The body reaching to its again original position back by the end of the 30th second, right? So this is in the shape of what? This is in the shape of trapezium, right? So this is the shape of trapezium. In mathematics, to find the area of trapezium, right? So let us consider this particular side as capital A, this base which is broader than the A, let us consider this as B. These two are unparalleled sides. These two are unparalleled sides, right? So, and these two are parallel sides. These two are parallel sides. And what is the height of the trapezium? The height of the trapezium is nothing but the y-intercept. The y-intercept will be the height of the trapezium. The y-intercept is 0 till 30, that is 30 units. 30 units is the height. 30 units is the height, right? So what is the area of trapezium? Anyone, if you know the area of the trapezium, you can comment in the chat box. So the area of trapezium is given by, see, we are finding displacement. For you need to find, see, for finding the displacement you need to find what? Area of the graph. So here, as the graph is in the shape of trapezium, I am applying the formula of area of trapezium. Area of trapezium. So what is area of trapezium? Half multiplied by height of trapezium into the sum of the two parallel sides, that is A plus B. Half h into A plus B. So when I am putting these values here, half multiplied by height 30 into A plus B, that is, so what is the A value? Can anyone? What is the capital A's value? Can anyone tell me in the chat box now? Capital A's value. So to get the capital A's value, it is nothing but the x-intercept. X-intercept. What is the A at the first point? Here, if you can see the x-intercept here 10. What is the x-intercept of the other point of A? It is 20. So 20 minus 10, it is 10. 10 units. So A value is 10. What is B value now? B value is 0 till 30. That is 30. So it is equal to half 30 into 10 plus 30, that is 40. So 2 ones are 2 20s are 30 into 20, that is 600, right? We got 600 square units. 600 square units as the area, but here area means displacement for us, right? Displacement is measured in what? What is the SI unit of displacement? The SI unit of displacement is meters. So here we need to write 600 meters as we got the area or displacement. Got? So area means displacement. What is the SI unit of displacement? That is meters. So let us see the answer now. The displacement is 600. Yes, the displacement for the given graph is 600 meters, right? Now going to the next question, and if you have any doubts you can comment in the chat box. Right. Now a stuntman rides a bike and his displacement time graph looks like an inverted parabola. I already told you what is inverted parabola. Inverted parabola means will be like looking like a, it will be opening downward and it will be looking like a small n like this. Okay, what does this tell to you? See, okay, so let us draw the graph properly for this situation to understand the condition more detail in a more detailed way. Let us deconstruct the graph now. So this is the graph as per the question. If you draw the graph, this is our graph. The stuntsman's graph is looking like an inverted parabola. Got it? So let us assume that the stuntman started his journey at 0 second mark. Okay. Now as it is a curve, right? Parabola means a curve, right? So the stuntman is not moving with a uniform motion. The stuntman is not under uniform motion, nor he is under a uniform velocity. Here the stuntman's motion is non-uniform and is completely variable. Okay, so in this scenario what we can conclude? So the stuntman's acceleration, okay, as it is displacement time graph, and we got the curve here, it means the velocity is not constant. The stuntman is having some acceleration, that is variable acceleration from the beginning of the journey till he reached the maximum position, the maximum displacement here, that is 25 meters. So after reaching the 25 meter mark, what happened? After reaching the 25 meter mark, the stuntman's curve again went downward, right? When the curve is going downward, it means the stuntman's motion is in the reverse direction. The stuntman is again coming backward to his original position, okay, by the end of the 10 seconds. Okay, so by the end of the 10th second, the stuntman came to his original position. Okay, so this is what this curve means. Now again, what about his acceleration here? What about his acceleration in this case? The acceleration not gradually decreased, the acceleration is also variably decreased in this case. Okay, so first his acceleration variably increased after reaching till the 25 meter mark, again his acceleration variably decreased. Now he is decelerating and returns to the, okay, let us go through the points one by one. The first one, he is accelerating continuously. You think he is accelerating continuously? No, right? Because first he accelerated variably after reaching the 25 meter mark, again his acceleration got in the negative direction, and because he is reaching to his original position. So this is not right. Now what about the third one? He is moving with a constant velocity. I already told you, in order to get a constant value, the graph needs to be having some straight lines, right? So as there are no straight lines in our graph and it is completely a curve, so it means it is variable, not constant. So this is also incorrect. Now what about the last one? He is flying off a cliff. See, if the stuntman is, think that for example, if the stuntman is flying off a cliff, right? A cliff would be somewhat higher than the sea level, right? And if he jumps from a cliff, he would be getting down to some valley or something, right? He would be going into some valley. The position would be changing now. The initial position and final position are not same. But here, as per the graph, we got that the stuntman returned to the 0 meter mark. It means again his initial position where the initial position where he started, again he has returned to the same position. So it is not possible while he is, you know, if he really jumping off a cliff, it is not possible, right? So these also are not the right answer. So if you see the option B, he is decelerating and returns to starting point, would be correctly fitting for the given situation. So first he is accelerating after reaching the 25-second mark, 25 meter mark. Again he decelerated and came to his original position. So this is what we can conclude from this particular question. Now next question, a particle moves with uniform acceleration. Now he gave uniform acceleration. Okay, so uniform acceleration, its displacement time graph is plotted and found to be a parabola. Okay, so in the displacement time graph, if you plot, okay, we get a parabola for the uniform acceleration. Now which of the following statements is always true? So let us first decode the question here. So for a displacement time graph, acceleration, if you want acceleration, or if you are plotting some acceleration, or if you are plotting the graph for the object which is under acceleration, you would be getting a parabola. You would be getting a parabola curve, right? So acceleration means non-uniform velocity, variable velocity. The rate of change of velocity is increasing. So that's why we are getting the parabola here. So here 4 statements are given. Let us see the 4 statements. The first one, the average velocity between any 2 points equal to the instantaneous velocity at the midpoint. Okay, the average velocity between any 2 points equals to the instantaneous velocity at the midpoint. Let us see here. So for example, if I am finding the average velocity between this point and this point, okay, I have to draw a straight line, right? I have to draw a straight line. So this straight line will be making some angle theta with the x-axis, right? I have to find tan theta for this to get the average velocity. Now what about the midpoint here? For the parabola, the midpoint, if you take the midpoint, again if you draw the straight line for the midpoint, okay, so here what happens now, the straight line, the tangent which you drawn, okay, at the midpoint to this parabola, okay, this tangent would be parallel to the line which you have taken first. Okay, you have first drawn a line which is passing through 2 points of this graph, right, to find the average velocity. So this line, okay, will be parallel to the tangent which you are drawing at the midpoint to the graph. Okay, as both the graphs are same, the tangent always gives the instantaneous acceleration, instantaneous acceleration, whereas the secant or the average acceleration, if you wanted to find, you need to take at least 2 points and you need to draw the line. So these both lines, as these both lines are parallel, the theta would be same here. The theta would be same. The theta which the lines are making with the x-axis are same. As the theta is same, the tan theta value is also the same. So if the tan theta is also the same, it means that the average acceleration and the instantaneous acceleration both are same in this particular scenario. The slope of the tangent to the graph gives average velocity. The slope of the tangent here they are saying. Tangent always gives the instantaneous velocity, not the average velocity. So this is the wrong statement. Now, the graph is a straight line when acceleration is constant. See, when there is a acceleration in the displacement time graph, okay, the displacement time graph always, it becomes a curve. Okay, so whenever you are seeing curves in the displacement time graph, it means acceleration, and if you are seeing the straight lines in displacement time graphs, it means uniform velocity. Okay, so the graph is straight line when acceleration is constant, they give. So when there is acceleration in the displacement time graph, it would be definitely a curve and not a straight line. So this would be a incorrect statement. Now, the area under the graph gives acceleration. The area under displacement time graph, okay, if you multiply displacement into time, will you get the acceleration? No, right? So by multiplying displacement and time, you won't get the acceleration. So this is technically also, this is an incorrect statement. The area under the graph gives acceleration. This is also incorrect. So the only one which is correct in the given 4 statements is the first one. The average velocity between any 2 points on the curve, okay, equals the instantaneous velocity at the midpoint. Got it? Now, a particle moves with uniform acceleration, its displacement, okay, fine, this is completed. Now coming to an assertion reason type question. The slope of a curved velocity time graph gives instantaneous acceleration. Okay, the slope of a curved velocity time graph, it is curved, right? Curved means variable. Curved means always variable. Velocity time graph gives the instantaneous acceleration, right? Okay, the slope of a curved velocity time graph gives instantaneous acceleration. The slope of a line joining 2 points on a curve gives the average acceleration. So whenever you are drawing any kind of tangent, okay, to the curve, and if you are finding its slope, which is making with the x-axis, it would be giving the instantaneous acceleration. So instantaneous acceleration would be given by the tan theta. Okay, theta is the angle made by this tangent, okay, with the x-axis. So tan theta would be giving what? Instantaneous acceleration. Instantaneous acceleration in this case. Okay, now again, I already in the previous question we already studied that if you are joining any 2 points on the curve, and if you are drawing a straight line, and if that straight line is extended up to the x-axis, and if the theta is measured and tan theta is obtained, that tan theta would be giving the what? Average acceleration. Average acceleration for the velocity time graph. So what they are saying in the reason, the slope of a line joining 2 points on a curve gives the average acceleration, right? So the second statement is right. What about the first statement? The slope of a curved velocity time graph. Here the slope means the slope of the tangent, okay, of a curved velocity time graph gives instantaneous acceleration. So this is also right. Both assertion and reason are true. And what about the reason? Is it rightly explaining the assertion? Are you thinking that there is a relationship between the assertion and reason here? Is both are true here. The assertion and reason both are true, but here the reason is not exactly explaining what the assertion means, right? So what is the answer now for this case? Both A and R are true. We know that A and R are true, but R is not the right explanation for A. The reason is not the right explanation for given assertion. Got it? So if a vehicle moves with variable acceleration, its velocity time graph can never be a straight line. Oh, already we studied that one till now, right? So when the object is moving with variable, any kind of variable motion, if it is under variable acceleration, always the graph would be a curve, not a straight line. Okay, so it would be automatically true. And the reason, a straight line velocity time graph implies constant acceleration. Now a straight line velocity time graph, okay, so if you are plotting a velocity time graph and the velocity time graph, if you are getting a straight line, a straight diagonal line, it implies constant acceleration. The velocity is gradually increasing, right? The rate of change of velocity would be gradually increasing. If you are drawing a graph here, velocity time, and if you are getting a straight line, it means the velocity is gradually increasing. The rate of change of velocity is increasing gradually, right? The rate of change of velocity is, the acceleration is constant because the velocity is increasing at the same rate with the time, right? So it means a constant acceleration, right? So what do you think? Assertion, reason, both are true? So if I wake, so reason is true, assertion is also true, and do you think the reason is correctly explaining the assertion there? Reason is correctly explaining the assertion. So here also it is velocity time graph, here also it is velocity time graph. So in the reason you have been given that the velocity time graph, if it is a straight line, it is constant acceleration, and if in the assertion it is saying that it is saying about the variable acceleration, and it is saying that it can never be straight line, right? So they both are supporting each other, right? So the reason is giving enough support for the given assertion, right? So what about this graph? So here if you see, here the green line represents a constant, the green line represents a constant acceleration because the velocity is gradually increasing with the time here. Whereas if you see the yellow line, the velocity first it is more, then it decreased by the end of the third second. Again from the third second the velocity started to increase, so it is not a uniform velocity, right? The velocity kept on decreasing, again kept on increasing. It is not a uniform velocity, it is a variable velocity, right? Variable, and also it is coming down, again going up. There is a deceleration as well as acceleration, right? So the acceleration is not said to be a constant here, it is completely a variable acceleration for the yellow graph, whereas constant acceleration for the green graph, right? So what can we conclude? We can conclude that both assertion and reason, the given assertion and reason are true, and the reason is the correct explanation for the given assertion. So these are some of the questions we discussed. So what we discussed today? We discussed in ST graphs like the displacement time graph, curves means non-uniform velocity. Curves, whenever you are seeing curves in the graph, it means non-uniform velocity. The second one, we saw the VT graph, that is velocity time graph. The straight line means the constant acceleration. Curves, if you are seeing the curves in the velocity time graph, they mean the variable acceleration. Now slope at any point, if you take on a parabola or any kind of curve, if you are drawing the tangent and you are getting the slope, it would be giving what? Instantaneous rate of change. Either it may be the instantaneous rate of change of velocity, okay, or instantaneous rate of change of displacement it would be giving. Now slope between 2 points on the curve is equal to average rate of change. If you are taking any 2 points on the curve, and if you are taking the average of them, you would be getting the average rate of change, whether it is acceleration or velocity. Got it? So now coming to the dream of cracking IIT. So you all wanted to crack IIT, right? So you all are coming from 8, 9 and 10 grades here who are excitedly listening to this session. So you all are very much having many kind of doubts. Sir, some of you are feeling this is very tough, some of you are feeling that this is very easy, and also some completely confused whether the IIT JEE, is it a right thing for me or a completely useless for me. So if you see, IIT is one of the toughest exams, okay, in the entire world, not only in entire India. IIT JEE, cracking IIT JEE Advanced is one of the toughest tasks in the entire world. Okay, so let me say you one line. A dream is not that which you see while sleeping. It is something that does not let you sleep. Know this line? Anyone know this line? A dream is not that which you see while sleeping. It is something that does not let you sleep. So this is the line which is said by Dr. APJ Abdul Kalam, our ex-president of India, and also is our famous rocket scientist, right? So if you wanted to crack IIT, your foundations got to be rock solid, right? You agree with me, right? Your foundation got to be rock solid. So because it is not a, I already told you, it is not a very easy task. Okay, so no shortcuts here. There are no shortcuts, no excuses. You need to build the base. You need to build the base to crack IIT. That's why we are taking these many sessions for you. Okay, all of you are from 8th, 9th and 10th grades. You need the foundation strong. That is the reason we are here. For that, Sisya is giving you the long-term course made for the grades 8 to 12. Okay, this is especially for you. Okay, so more than the YouTube series, more than what you are watching on the YouTube series, you would be getting, the more details, the more delve into concepts. Okay, so in this foundation course which is provided by the Sisya, it's a launch pad crafted by the real IITians. Okay, the people who have walked through the path that you are now aiming for, that is cracking the IIT JEE exam. Now, so let me ask you one thing. So before going into this, so why early start is important? For example, you are just in the 8, 9 and 10 grades and the IIT JEE is for the 12th and 11th standard students. What is the need for you? Success is success in life, right? So if you want success in life, you just don't want the success in your school, but you want success in your whole life, right? So success in life does not come from shortcuts. It comes from strategy, right? So you need to think sharp. You have to move smart and you have to win the big game, that is the JEE exam. Now, if you want to be the player, you have to begin from today itself, because the time is very less and the syllabus is so much vast to complete. So IIT JEE syllabus is not a small thing to cover up in a one night or two night, or even, believe me, it is not the syllabus which you can complete in the span of 2 years. You need at least 5 to 6 years of foundation for that. Okay, so you all not just become an engineer, you'll become unstoppable with Sisya's JEE foundation course that we are offering currently. IIT is a marathon, okay, and I want you all to win in that marathon. Okay, and to win in that marathon, you don't need just speed, you need discipline by managing time, and also you need critical thinking skill. Got it? And also you need to have the time mastery. You need to know how to attempt, how much time I have to take to attempt each and every question, how much I have to spend on each question. Everything should be calculated in the mind. So that much fast you have to be. Now this is where Sisya steps in, students. We don't just give you the content, we give you the right mindset. We don't just only give you how to solve the problem or how to apply this formula, this kind of thing, that kind of thing. No, we are going to teach you the plan and the right mindset that you need to conquer this JEE exam. Okay, so by the time others even start, Sisya students would be crushing the round one. Okay, with the fast mind and the fierce moves, you would be the first to finish. Okay, that is the Sisya's way. Always one step ahead you have to be. Okay, so early start gives you the top results with less pressure. Got it? Always be early, be early, be early, be early. Trust me, the ones who start early are the ones who lead always. Okay, so if you are starting early, you would be leading many others who are aiming just like you. If you are becoming lazy, okay, you would be falling behind. Someone will be there to take your place. Now, not just in exams but also in life, I want you all to succeed. Now, coming to the teachers, Sisya's JEE foundation teachers, let me introduce to you. So these are our expert teachers who cracked IIT by themselves. All of the Sisya's teachers are the IIT crackers. They don't just teach theory, they share their own experience of cracking IIT JEE, how they studied, how they struggled in their life to crack that exam. Everything they are going to tell you. They are going to share their experiences with you. And when coming to the syllabus, what the Sisya is going to offer you, the syllabus of the JEE Foundation, it is completely based on the 11th and 12th standard. From the basics to the beast mode, you will be getting the complete 11th and 12th JEE level syllabus. We don't skip steps, we climb them one by one. Okay, all the Sisya students, already the students who are enrolled in, they are already working on, they have completed so many levels and they are truly ahead when compared to all of you who are watching now on the YouTube. Now physics, chemistry, maths all covered in a way that a confused student will be becoming a troubleshooter for the any other learner. Okay. Now when coming to the Sisya's classrooms, not only studies, you will be seeing your own progress building up every week. Every week we are going to provide you the progress what you are making in the learning IIT JEE, taking IIT JEE Foundation. Okay, so because someone has to there to guide you, someone has to point out the mistakes you are doing. How, see, they have to see, without right guidance you cannot go in the right path. Okay, so with the live rankings, quizzes, real-time tracking, you all know where you are standing, okay, and where you need to level up. Remember, IIT is a game and you are the main player. Every day is a mission here in Sisya's classroom, and every quiz is a challenge, and you are here to win every exam right now from today itself. Now, not only the studies, not only the classes, we are going to give you all the support that you need. Okay, we are going to give you all the support that you need. Sisya means support for the students. Sisya is not just a class, Sisya means support. This is not just another coaching platform, my friends. So utilize Sisya's 24/7 AI, okay, AI to find the answers to all of your subject doubts. Sisya's one-on-one mentors are also there for you, available online, and are waiting to connect with you to become a part of your success journey. They are available on our WhatsApp channels as well as the Facebook and Instagram channels. You just say hi to them, they will be all connecting with you, and they are going to help you wherever. If you are facing any kind of issues in your JEE struggle and journey, they are going to guide you each and every step. Okay, now here teachers, mentors and AI, everyone in the Sisya all team up, okay, to make you the hero of your JEE story. Okay, now what about self-study? Sir, I can self-study. Okay, so I know I don't need guidance, I can study by myself. So here self-study means not solo study at Sisya. We are going to provide worksheets, daily practice papers, digital study packs, all designed carefully by our IIT faculties to make you think, question and dominate concepts. Okay, so we don't believe in spoon feeding, we train you to work smart and conquer. Now coming to the master level, level up your answering and time management skills with Sisya's bi-weekly test, which they are available in the app, Sisya app. Okay, you can directly randomly go through those mock tests, okay, day by day, and you can practice all the numericals which are coming in those mock tests. Now, and you are going to experience the real pressure of writing the JEE exam. Okay, by doing this, what is the benefit for you? You are going to experience the real pressure. How writing the real JEE exam will give you the experience. How much time management skills you have, whether you are utilizing your time properly or not, how much time you are spending on each and every question will be tracked by the app, and it will be giving you the right guidance. Okay, so on the day the real JEE exam comes, for you it's just another normal day. Train hard, win easy. Sisya always supports you. This is not just an ordinary course, this is a premium course crafted by India's top minds. Now all parents, think about this. The parents who are watching now on the YouTube, so please think about this. What is the price of building your child's dream? Right, you all want your child to be a very good engineer, to be placed in a very good MNC like Google, Facebook, anything, Netflix, Amazon. So what is the price you are going to pay for that? is your child is getting the real education or not, right? What's the cost of seeing your child in an IIT, making you proud, building the name for themselves, for your family? At present, in our India, around the world, it's lakhs of rupees due to the market inflation. We observed that the real talented students are not getting enough support for building their dream, right? At Sisya, it's our mission to make everyone happy and get valuable education at an affordable price. So we have made this entire premium JEE foundation course. See, let me show you the real prices first. The original prices, to understand how valuable this price is. So for the market comparison, if you are getting a IIT foundation course for the grade 8, you would be getting approximately at 89,999 rupees from any other JEE foundation provider that you see. For grade 8 and 9 or 10, you would be getting around 90,000. You need to spend nearly 90,000 a year, right? So these are standard market rates. We are opting for the premium IIT coaching that is also taught by the real IITians, not just ordinary teachers, real IITians with AI powered support, personal mentors, and a live interactive training we are going to give. So this is a special package we are offering through the real IIT teachers at an affordable price. And honestly, even at this price, it's worth it because it builds not just a student but a thinker and a leader. You are not only getting the basics of foundation, but you are getting all the experience from the real IITians who cracked the exam. They are going to share all of their life experiences, all of their mindset with your child, and believe me, it's worth every rupee. But you have gone one step ahead. We have at the Sisya, we all gone one step ahead for early birds like you. You all paying so much interest on the YouTube, right? So you all coming every evening for us, to learn something, to at least learn something from physics, chemistry, maths, from the Sisya class YouTube channel. You all are coming for us, right? So you all are, I hope, the real early birds who wanted to get some knowledge. Okay, so instead of spending on some games, mobile games, or watching some movies, you are here and watching our sessions, how to solve the problems, right? So you have the willpower, right? You all have the willpower. You are coming to our YouTube channel daily and trying hard to understand the concepts taught by all of us. We are so thankful to you guys. You all the real heroes, the upcoming heroes, right? So we, for the sake of you today, so in this session, I am going to show you this offer is just for you who are attending this session, right, in the live and watching the Sisya's YouTube channel, right? The Sisya's JEE series on YouTube channel. All of you who are watching now, for you we are providing for the limited time all the premium course, which is costing nearly 89,999. Sisya is offering just for 14,999. 2.7 lakh rupees. You can see the full valued package, right? See, for all the grade 8 to grade 12 students, the 5-year complete package will be costing you around 2.7 lakh. That whole package we are just offering only for our subscribers who are watching our YouTube session now. We are offering just for 39,999 rupees, right? Cheaper than the smartphones that most of you are currently using. But listen, only the limited seats. That is also for the viewers who are right now. You just comment your name and comment I love Sisya on YouTube right now to get the chance of winning this golden opportunity, right? But listen, only limited seats and only the comments from you are considered. If you are really watching this session, just comment, just enroll in JEE Foundation series on this video stream now, and you would be getting the offer, right? So don't be disappointed later when you see the actual price on our website. So on our website, you are going to see only the original prices, not the discounted prices. Now download the Sisya class app when you just act at the right time. Okay, so if you have any queries, you just download the app and you can find all the material which you need, all the material or all the mock tests, all the details of our courses, everything you are going to get on the app. Okay, so Sisya's long-term JEE foundation is your first step towards the IIT success. Enroll now before someone else take your spot. Okay, so thank you. So this is Ram Prasad signing off for today. So again, I will be meeting you in the another session. So in the upcoming week. Thank you. Bye bye.